Okay, I'm back. Part two. So I just gave you an example of how to write a direct variation model. So this is another example that I want you to try using the example we just wrote down in our notes. So the variables x and y vary directly, and y equals 6 when x equals negative 3. So I want you to write an equation that relates x and y, and then I want you to find x when y equals 10. So I want you to pause the video. I want you to try this problem, and once you think you have answers, I want you to play the video to check. So go ahead and pause. So now that you've tried it, hopefully these were the steps you went through. The first is to write the direct variation model, y equals ax. Next is to substitute 6 in for y and negative 3 in for x, and then solve for y. And you can see my work there. You should get a equals negative 2. And then you must rewrite. Step 3 is to rewrite the equation, the original model, only putting in a for the variable a, so y equals negative 2x. So that's the equation you need to come up with. And the last part, when you were supposed to find x, when y equals 10, I switched it from the original example. So this time you put in 10 for y, and then you had to solve for x. So see how I set that up, and you get x equals negative 5. So hopefully you were successful with that. All right, we're going to move on now and look at an inverse variation model. So we're continuing on in your notes. So here's my example. Write an inverse variation equation. The variables x and y vary inversely, and y equals 7 when x equals 4. So this time we're going to write an equation that relates x and y, which we did before, but this is a different variation model. And then we're going to find y when x equals negative 2. So we're going to go through the same 4 steps, but because this equation's, or this problem said inverse, we're going to start by writing the inverse variation model, which you can go back in your notes and see that we wrote it. It's y equals a divided by x. Step 2 is then to substitute y equals 7 and x equals 4 and solve for a. So I'm going to put the 7 in for y. The a is on top because we're going to solve for it, divided by x, which is 4. To get a by itself, you multiply both sides by 4, and you get a equals 28. Step 3 is to rewrite that inverse variation model now with your a that you just found. So you would write y equals 28 over x. So that's the inverse variation model that we want. And in order to do the last part, which was to find y when x equals negative 2, you substitute negative 2 in for x in that equation that you just wrote, and 28 divided by negative 2 is negative 14. Okay, so again, please pause and write what you need to write down and reflect. And then I have another example that I want you to try this time with inverse. So this time I have the variables x and y vary directly. Whoops, I'm sorry. Wrong one. I just did that. I apologize. All right, here we go. The variables x and y vary inversely. Use the given values to write an equation relating x and y. Then find y when x equals 2. So the original x is 4 and the original y is 3. So same as before, pause the video. When you have answers, play the video to check. Pause your video now. You can check your answers. Step 1, write the inverse variation model, y equals a over x. Step 2, plug in 4 for x and 3 for y and solve for a. So 3 equals a over 4. Multiply both sides by 4. A is 12. Step 3, rewrite the inverse variation model using 12 as a. So y equals 12 over x. And lastly, in order to find y when x equals 2, use that model plugging in 2 for x, and 12 divided by 2 is 6. So how are you doing? Hopefully you're getting this. I know this is a different way to learn, and I would be checking your understanding if we were in class, and I'd be going a little bit slower, but because you can stop, pause, and rewind, I think we're okay. And when you try to do these on your own, that's when you reach out to me if you're struggling. All right, one more variation model, and it's joint. so I will not cover stuff up this time. So joint variation equation, the variable z, that's a z everyone, varies jointly with x and y. Also z equals negative 75 when x equals 3 and y equals negative 5. So this time we're going to write an equation that relates x, y, and z, and then we're going to find z when x equals 2 and y equals 6. So same 4 steps. Step 1, write the joint variation model as it's stated, and I wrote it that way because in words it says the variable z varies jointly with x and y, which is the model I originally gave you. But if they wrote it a different way, we would write it a different way. So we write it in that order. Z equals A times X times Y. Step 2, substitute the Z, negative 75, the X 3, and the Y negative 5, and solve for A. So negative 75 equals A times 3 times negative 5. Since 3 times negative 5 equals negative 15, I divide both sides by negative 15, and I get A to equal a positive 5. So knowing A, I rewrite the joint variation model, putting 5 in for A. So my model is now Z equals 5 times X times Y. And lastly, to find Z when X is 2 and Y is 6, I plug in the 2 for X and the 6 for Y. And in this case, I multiply 5 times 2 times 6, which is 60. Okay, so again, pause, stop the video, rewind the video, write this down, reflect, and then I'm going to let you try. Okay, so cover up the answers. This is the one I want you to try. The variable z varies jointly with x and y. Use the values x equals 1, y equals 2, z equals 7 to write an equation relating x, y, and z. Then find z when x equals negative 2 and y equals 5. So same as the other two, I want you to pause the video. I want you to try this in your notes. And when you're done, play the video and see if our answers are the same. So step 1, write the joint variation model. Z equals A times X times Y. I plugged in 7 for Z, 1 for X, 2 for Y. 1 times 2 is 2, so I divide both sides by 2. 7 cannot be divided by 2 evenly, so I leave it as an improper fraction, 7 halves. Step 3, I write the model, z equals 7 halves xy. And then to find the last part, find z when x equals negative 2 and y equals 5. I plug negative 2 in for x, 5 in for y, and I multiply it by the 7 halves, and I should get an answer of z equals negative 35. I'm going to pause at this time. We have just a little more notes to take.